Hey guys, welcome to the Level 3 Calculus 2019 Integration Exam Paper. So the way this video is going to work is that I'm going to go through each question, let you guys know what you need to do for achieve merit and excellence. Now, the best way to use this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video and check the answers that I've actually done, and then see how far you got with the answer. Cool. So without further ado, let's get started. All right, guys, so we are getting into this. So question 1A, what we have got here is we've got always, as always, a nice and simple little integration question to start the paper with. So we're going to integrate this. But before we integrate this, what we need to do is bring that square root of x to the numerator and write it in a power form so that it's actually easier to understand. So what I'm going to do is I'm going to rewrite this as 2 over x to the power of half dx. Then I'm going to bring the x to the power of half to the numerator, and when I bring it to the numerator, it is going to become minus half. And now I'm going to start, integrating it. So integrating 2 becomes 2x, and I've got 2x negative half. I needed to add 1 to the power, and of course divide by the new power, which happens to be negative half plus 1. And of course, don't forget, you need the plus c at the end as well. All right, now you can actually leave it like this, but if you're going to leave it like this, what I would actually recommend is putting a couple of brackets. But, you know, ideally, it's just you want to simplify this a bit further. So we're going to rewrite this as 2x plus 2x to the power of half over half plus c. So that is pretty much what you need to do for this question here, and that is going to get you an achieved. All right, the next question. The trapezium rule question. I mean, this question, all it is just, you know, getting the formula and actually substituting it in and just solving it. That's all it is, all right? Just give me a second. I need to go grab the formula first. So what I've done is I've just copied the formula from the formula sheet. It is given to you guys. And it's just a matter of just replacing all those things from the table. All right, so what I mean by that is we've got 5, which happens to be the value of b. And then we've got 2, which happens to be the value of a. And then n is how many of these do you actually have, all right? So we're going to put this as y0, y1, y2, y3, y4, y5, and y6. So basically, that 6 there is your n. So now it's just a matter of actually putting all of this formula down and copying it down. So what we have is we can actually say that half multiplied by h. Now h is b minus a, so b was 5 minus 2 divided by n, which is 6, multiplied by y0, which happens to be 0.6, plus y6, which is 2.6, plus 2 times all the inside terms, which is 1.1 plus 1.7, 2.6, 3.2, and 3.4. So putting this all in the calculator, we should have our answer. So let's just go to that menu. And what do we have? We've got 0.5 multiplied by 5 minus 2 over, that's 3 over 6, which is another 0.5. Multiplied by bracket, and we have 0.6 plus 2.6. It's just easier using this. Plus 2 times what is all in the bracket, 1.1 plus 1.7 plus 2.6, 3.2 plus 3.4. And that gives me an answer of 6.8. I have to say, for an achieved question, it is a lot of work. Yeah, And you know, and it's like one little mistake that you make and you end up with a completely wrong answer, and that means you don't even get that achieved grade. So it's just being very careful about your substitutions. That is all. Okay, so let's go to question C. All right, guys, so with question C, what we have is we've got the classic substitution of a particular formula. Now, the way we go about doing this is that if you look at these two little cos things, they're getting multiplied, right? And because they're getting multiplied, we can actually use the formula sheet and see if we can grab the product thing right there. There we go. So we got 2 cos A, cos B. Let me just put that down there somewhere. So 2 cos A, cos B is the one that I'm going to be using. 2 cos A, cos B equals, what is it? Cos of A plus B and plus cos of A minus B. So this particular one is the one that I'm going to be using. So if that's the case, then what I can then say is I can actually say that cos A cos B equals half cos of A plus B plus cos A minus B. And so literally what I've done here is I have just called this 4x as cos of A and cos of 2x as cos of B. So by doing this, what's going to happen now is I'm going to replace cos 4x and 2x with this green thing here, which means I'm going to get it between pi over 12 and 0, and I've got half cos of A plus B, so that's going to be 4x plus 2x, which is 6x, plus cos of A minus B, so 4x minus 2x is 2x, is what I'm going to be left with here. And because that half is actually in front, I can take the half out of the integral function, and I'm going to end up with half of pi over 12 to 0, and this is between cos of 6x plus cos of 2x. And of course, don't forget the dx there as well. So now I can actually integrate this because the two terms are separate and they're by themselves. So I'm going to have it by half cos x. When I integrate it, I'm going to get sine 6x, and of course divided by whatever's inside this bracket here, which is 6 in this case. And I've also got plus sine of 2x divided by the differentiation of whatever's inside the bracket, which happens to be 2 in this case. And of course, this is all between pi over 12 and 0. So at the next point, what I'm going to be doing is substituting these values. So I've got a half of sine of 6 pi over 12 over 6 plus sine of 2 pi over 12 over 2, and that whole thing is subtracted with sine of 0 over 6 plus sine of 0 over 2. Now that sine of 0 part is all going to be, what do you call it? It is going to be 0 anyway. So I'm just going to work out the sine 6 pi over 12 first. So what have I got? I'm going to do sine of 6 pi over 12. Sine of 6 pi over 12 divided by 6 plus sine of 2 pi over 12, and that's divided by 2. Oh, where have I made a mistake? So that gives me 0.41667, and then of course I've got half of that, so I've got to multiply it by 0.5, which gives me that, and if I convert that to a fraction, I get 5 over 24 as my answer. Now, you could have actually done basically you know, instead of putting this in the calculator, what you could have done is you could have actually gone into your options, calculus mode, integral, and with integral, you basically type in cos for x. I might want to put this in a bracket because I'm always nervous about doing this with, but we'll see how it looks like. Cos 4x and then cos 2x. And I want it between 0 and pi over 12. Pi over 12? Yeah, pi over 12. So as you can see, I can convert this to a fraction. It is not going to let me convert to a fraction, which is quite annoying, but that is still going to work out, isn't it? Yeah, so as you can see, they're both still the same answers. All right, so you can actually use that integral function to get the final answer. Yeah, so 5 over 24. So in terms of grades, correct integration gets you guys an achieved. So I'm guessing here is where you're going to be getting your achieved. Correct solution with correct integration gets you a merit. Cool. So let's go to the next question. All right. So question D, what we have is we've got a graph between blah, 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 and then to show that the area of the regions A and B are equal. Okay, so a couple of ways of doing this particular question is you could actually do it between 15 and 5 and then 5 and 0 and then prove that both of them are equal to each other. Or you could actually work out this area here. So you could actually work out the full area of the pink part here, and then you could work out the green part and then show that the green part is actually half of the pink part. Now, the reason why I'm doing this one is because I'm calculating it between 0 so that I don't have to actually do too much substitution. So what I mean by that is my first part I'm going to do is the pink area here. So for the pink area, it's between 16 and 0. And I've got 6 square root of 3x plus 1 dx. So I'm going to actually work that out first. Let's kind of go here. And then the green part, for the green part, it's going to be between 5 and 0. And that's between 6 over 3x plus 1 dx. All right, so I'm hoping you guys can understand what I'm trying to do there. Is I'm going to try and work out the pink area first, then I'm going to work out the green area, and then I'm going to show that the green area is actually half of the pink area. So to work out the pink area first, I'm going to do that here. Now that's, before I get started, I want to actually bring that square root symbol to the numerator. So this is going to become 6 multiplied by 3x plus 1 to the power of negative half dx. And then when I integrate this, I'm going to get 6, 3x plus 1. Now negative half plus 1, negative half plus 1, divided by the new power, which is negative half plus 1. And also, we've got to keep in mind that we've got to divide by whatever the differentiation of the bracket here is, which ends up being 3. And all of this is between 16 and 0. So if I was to simplify this, what I've got is that 6 and 3 disappear first. So I'm talking about this and this, which is going to make it 2. And I've got 2, 3x plus 1 to the power of positive half, divided by half, negative half plus 1 is another half. And this is all between 16 and 0. Now, I'm going to keep simplifying this as low as possible because then substituting things becomes really lot easy. So 2 divided by half is 4. So I've got 4, 3x plus 1 to the power of half, and that's between 16 and 0. So when I do this, I'm going to get 4 times 3 times 16 plus 1 to the power of half. Now that's equal to 4, I've got 49 to the power of half, which equals to 7. And 7 times 4 is, no, have I made a mistake here? Yes, I've made a mistake here because that zero, that stupid zero, I forgot about the zero. Yeah, no, that's all right. So I've got to do the zero as well, guys. So apologies about that. Which means I'm going to get 4 times 3 times 0 plus 1 to the power of half. So here I'm going to get 4 times 1 to the power of half is just 1. So that's going to give me, what do we got? 49 half is 7. 7 times 4 is 28. 28 minus 4 is 24. So basically what that means is that the pink area is equal to 24. Now I need to do the green area, but for the green area, because they're the same equations, I literally just need to go from here, and I'm going to write this as 3x plus 1 to the power of half, and I want it between 5 and 0. And if I do that between 5 and 0, I'm going to get 4 times 3 times 5 plus 1 to the power of half minus 4 times 3 times 0 plus 1 to the power of half. So here I'm going to get 4. Here I'm going to get 4 times 4, which is 16. 16 minus 4 is 12. And as you can see, the pink area is actually double that of the green area. So we can actually write a statement. Therefore, A is equal to 12, and A plus B equals to 24, and so B is equal to 12. Therefore, A is equal to B. So grades wise, what are we looking at? Correct integration gets you an achieved. That means we're looking at somewhere here to get an achieved. And final answer will get you a merit. So a question like this, it's, how do I say it? It's not about, it's just laying it out, guys, like just setting it up and then kind of like working through each part one at a time. And again, if you're unsure of how to do this question, as you can see, like just integrating it gets you an achieved. So keeping that always in your mind that you can actually integrate to get, just like differentiation, when you differentiate stuff, you get achieved. In integration, pretty much the same idea. All right, so let's go to the next question. All right, guys, so with the question 1E here, what we've got here is a classic, it's actually a nice differential equation, to be honest, to get started. So let me actually show you guys how to work this out. The first thing we need to do with differential equations is bring all the variables on the right side. So in this case, I'm going to bring this as 1 over n, d of n equals k of dt. So at this point, what's going to happen is I'm going to chuck in the integral sign for both of them. Remember that when I do 1 over n, integration of that is going to be ln of n equals, and then in this side I'm going to have kt plus c. So this is our first kind of like achieve separate variables and correct integration. So this part right here is going to get you an achieved. Now, if you look at the second part of the question, it says if n has positive values n1 and n2 at t1 and 2t1. So in other words, when it's t1, we have n1, and then when it's 2t1, we get the value of n2. So all it is that we've got to just substitute these two values into this equation that we got here for what we did for achieved. So our first equation is going to be ln of n1 equals k of t1 plus c. And then our second equation is going to be ln of n2, which is equal to k of 2t1 plus c. So what we've really set up is we've got a couple of simultaneous equations. So if that's two simultaneous equations, then all we have to do is kind of get rid of the c's. So we can actually go subtraction, all right? So, and because they want n2 at the top, so that means it's going to be slightly different but that's all right. We can still work around it. Just thinking, should we do it that way? Nah, it's fine. Let's do it this way anyway. Let's see what happens. So I'm going to subtract this, right? Alternatively, you could also use rearrange and substitute if you want to. Whatever works for you. I'm just trying to, yeah, let's do subtraction. So I'm going to go that, minus, and minus. So basically what that means is when I got ln of n1 minus ln of n2 equals k of t1 minus k of 2t1, and the c minus c just becomes 0. So the next step is looking at k as a common factor, and I'm going to get t1 minus 2t1, and then on this side I'm going to get ln of n1 minus ln of n2, and here t1 minus 2t1 is negative t1. Here I'm going to get ln of t1 minus ln of n2, sorry, not t1 before. So at this point, because I want to bring k by itself, so I'm going to get rid of the negative t1 to the left hand side, and when I do this, I am going to get ln of n1 minus ln of n2 divided by negative t1. But if I go back to the proof, you can see that the t1 has to be positive. All right, because it's positive, so what I could do is I could take the negative to the numerator, and it's going to become ln of n1 minus ln of n2 divided by t1 equals to k. And now, because that negative is there, I can bring the negative, expand the brackets, and I'm going to get minus ln of n1 plus ln of n2 divided by t1 equals to k. And I can do one more thing here, because I can actually rewrite this as k is equal to ln of n2 minus ln of n1 divided by t1. And remember with the log rules that we can actually say k is equal to 1 over t1 ln of n2 divided by n1. And the reason we can say that, because remember that ln of a minus ln of b equals ln of a over b. So this is actually one of your log rules that you actually have. And if you now go back and have a look at that proof, I believe we've actually proved it using just simultaneous equations there. So I've told you guys what you need for achieved. For merit, correct equation involving n1 and n2. Involving n1 and n2. So that means you've got to probably get somewhere here. So as I said, you could have actually done this question in a different way. You could have rewritten this as c is equal to ln of n1 minus kt1, and c is equal to ln of n2 minus k2t2, and then you could have actually put the two c's together and did it the other way as well. And final answer gets you, obviously, getting it to the proof gets you an excellence. So, wasn't a bad differential equation for an excellence question. Cool, that's question 1, guys. All right, guys, so let's get going with question 2. Question 2, once again, we're starting with a lovely, simple integration. So we're going to integrate this. We got 1 plus 2e4x dx. So integrating this, 1 integrates to x. Exponentials, we always leave it as it is, but we have to divide by the differentiation of whatever the power is. In this case, it's going to be 4. And of course, don't forget your plus c. So simplifying this, if you need to, you're going to get x plus 0.5 e to the power of 4x plus c. All right, lovely, lovely way to start the paper. Well, not the paper, the question. Get an achieved grade there for this. Moving on to number 2. Oh, should I say 1b? Okay, so question 1b, what it's asking you is to find out the area between b and negative b. So b and negative b is this area right here. So a couple of things to kind of keep an eye on is these two values here and the area that's actually given here. So notice how it's between a and negative a. All right, if it's a and negative a, what that basically means is, I'm just going to color these in pink area here right now, just so you get an idea, all right? So basically, we've got the first lot of pink area plus the green area plus the second lot of pink area equals to whatever their blue value is, which is, so we got that plus that equals this, all right? Here's the kicker. And I do mean this is as a kicker, all right? So this 5.8, that's sweet as. Yeah, we can put that down here. The green area is what we're trying to figure out. The kicker is that the purple area is actually below the x-axis. And because it's below the x-axis, it's going to be negative 1.2 and negative 1.2. All right, and this goes back to the idea right here. Because they calculated between positive a and negative a, what's going to happen is the area, whatever area is above the x-axis, it'll add to the area below the x-axis, but whatever's below the x-axis is going to come out as negative. So you're going to get negative 1.2 and negative 1.2. And of course, the green area still is what we're trying to figure out. So let's just put that as, I don't know, G, for example. So rearranging this, we got G minus 2.4 equals 5.8, and then G is equal to 5.8 plus 2.4, which actually gives you 8.2 as the area. Grade for this is a nice achieved. So it is just be careful about those little tricks that they put in, all right? A lot of people just go, oh, it's 5.8. I just subtract 2.4 from it, so my final answer is 3.4. Boom, incorrect. All right, so you've got to be observing of where that graph is, whether it's actually below the x-axis or above the x-axis, and that actually changes things up. All right, let's go to question C. So with question C, what we have got here is find K so that this is equal to blah, blah, blah. So what we're going to do is we obviously have to integrate this. Now, the key thing is that looking at the denominator, you've got x in the denominator, which means this is going to be ln. So we're going to integrate this, and we're going to get 8 ln of 2x minus 5. And of course, you got to divide by the differentiation of whatever's inside this bracket. In this case, it's going to be 2. And that's all between k and 3. We're going to simplify this. So we got 4 ln of 2x minus 5. And our two limits are k and 3. And this is equal to 10. Now, just getting up to this part right here, just this integration part is going to get you an achieved. And we're going to keep carrying on with this question to see what we need for the merit. So we've got 4 ln of 2k minus 5 minus 4 ln of 2 times 3 minus 5. And all of that is equal to 10. So remember that, what do we got? 4 ln of 2k minus 5 minus 4 ln of 6 minus 5 is 1. So that's ln of 1 is 0. So all we're left with is 4 ln of 2k minus 5 is equal to 10. 10 divided by 4 is 2.5. So we can rewrite this 10 over 4. And as always, I'm going to run out of space. That's all right. Just do these extra steps here. 2.5. Now, if I want to get rid of that ln, I can put that as e, which means I'm going to get 2k minus 5 is equal to e to the power of 2.5. Now, rearrange it. So e to the power of 2.5 plus 5, and then k is equal to e to the power of 2.5 plus 5 divided by 2. So you can actually leave your answer in this particular format, and that is going to get you a merit for this question. Nicely moving along with this one. All right, so let's go to question D. Whoa. So question B, what we've got is we've got cos squared x, and we want to find out the area of the shaded region. So a couple of ways of doing this. You could actually go from pi to 0, or you could actually go from pi over 2 to 0 and double it, whichever one you want to do. It's absolutely, it'll work fine. But the thing is, we can't integrate cos squared x, so we've got to substitute, get it out of the way. So in other words, I'm going to do it between pi and 0, and I've got cos squared x dx. Now, just to be on the safe side, what I'm going to do is I'm going to actually work out this value straight away, so that I know that I'm going to get the right answer. So cos squared x, and I'm looking for between 0 and pi. Which is giving me 1.57. All right, this looks like it could be pi over 2. Let me just double check that. Right, so my final answer is got to be pi over 2. But I need to actually kind of do all this integration part to actually show how it actually works out. All right, so let's go and find out where my formula sheet is. Okay, so the one I'm actually looking for right now is this one here, because I want to rearrange the cos squared a. So I'm just going to copy that down in my paper first. So we've got cos 2a equals 2 cos squared a minus 1. All right, so let's go back to this. So that's the formula I'm going to be working out of. But of course, I need to rearrange this. So it's going to become 1 plus cos 2a is 2 cos squared a, and then cos squared a equals 1 plus cos 2a over 2. So once that's done, I'm going to rewrite this whole integral sign again, but this time I'm going to put a half, and I'm going to write that as 1 plus cos 2x. Because I've taken the half out, I can just leave it like this, which means I can take the half out of the integral sign again. So take the half out of the integral sign, and it's between pi and 0, and I've got 1 plus cos 2x dx. Now, unfortunately, this does not get you any grades yet because you haven't actually done any integration. And remember that this is where people get kind of confused. They look at this and then they substitute their values and think they've done the integration. So you've actually got to integrate first. So that means I've got half outside. Integrating 1, I'm going to get x plus cos 2x. Integrating it is going to become sine 2x divided by the differentiation of whatever that inside the bracket is. In this case, it's 2x. So that means I'm going to get 2. And of course, this is all between pi and 0. Nope, don't have much space. So then I've got to expand this out. I've got half multiplied by pi plus sine 2 pi over 2 minus 0 plus sine of 0 over 2. And I can straight away see that sine of 2 pi is 0, so that's going to become 0, minus 0 plus sine of 0 is 0. I've got half pi. And I'm confident here because that's what the calculator, when I did it in the calculator, that's what I got. So I'm going to leave it with this one as half pi as my final answer. So grades wise, correct integration gets you guys an achieved, so which means we're looking about this step here to get an achieved, and then your final answer is going to get you a merit. Okay, so let's go to question E. Yeesh. You know, I hate questions when it's so big and you got no space to work with, but let's give it a go. Right, so the question's not actually too bad because all you have got is you've got two ugly looking graphs and you want to find the area between them. So the first thing we want to do is we want to actually try and figure out what is the x value of where these two curves actually meet. So that means we've got to put both of these equations equal to each other and try and figure out that x value. So that's our first step. So we've got e to the power of x squared equals 20 minus e to the power of x squared. So remember that when you have powers of powers, the two powers get multiplied. So this is going to become e to the power of 2x equals 20 minus e to the power of 2x. Rearranging this, I'm going to get e to the power of 2x plus e to the power of 2x equals 20, which means 2e2x equals 20. E to the power of 2x is 20 divided by 2, which is 10. And then 2x, getting rid of that e, I can rewrite this as ln of 10. So x is equal to ln of 10 over 2. So this point right here, that's going to be ln of 10 over 2. I think it might be a marking error, schedule error, but that's all right. Let's kind of work through it anyway. Okay, so we found this point, right? Now we know that the area is between this point and 0. So that means we can actually write this as integral of ln of 10 over 2 and 0. And then, I don't know if you guys have been watching my videos, but you basically just go top minus bottom dx. So the top graph minus the bottom graph. So here we're going to get ln of 10 over 2, 0. The top one is the 20 minus ex squared. Minus the bottom one, which happens to be e to the power of x squared. And of course, don't forget the dx. So we're going to go ln of 10 over 2 between 0, and we got 20 minus e to the power of 2x minus e to the power of 2x dx. Putting this together, I'm going to get 20 minus 2e 2x dx. So far so good. Integrate this. When I integrate this, I'm going to end up with 20x minus 2e 2x divided by the differentiation of the power, which happens to be 2, and that's between ln of 10 over 2 and 0. So what we're going to end up with is 20x minus e to the power of 2x. That's all between ln of 10 over 2 and 0. All right, so far so good. Now it's just a matter of substituting everything in and try and solve it. So we're going to have 20 multiplied by ln of 10 over 2 minus e to the power of 2 times ln of 10 over 2 minus 20 times 0 minus e to the power of 2 times 0 is what we're going to work with so far. 20 over 2, that's going to become 10 ln of 10 minus the two 2's cancel out here, and then e of ln of 10 is just 10 minus 20 times 0 is 0 minus e to the power of 0 is 1. So we've got 10 ln of 10 minus 10 plus 1, which gives us a final answer of 10 ln of 10 minus 9. How do we know we did it right or wrong? Well, let's check it out here. So we're going to go integral. Where's my calculator? Wrong one. So we're going to go integral. And what was that ugly looking equation that we had? 20 minus 2e2x. That's the one. 20 minus 2 shift e to the power of 2x. And we wanted it between 0 and ln of 10 over 2. Talk about ugly numbers. Okay, so it is giving us an answer of 14.025. Let me actually calculate what 10 ln of 10 minus 9 equals. And if that equals to that, there we go. We're on the right track. All right, so it's always a good idea with these types of questions to use your calculator to check what answer you're getting. And if your final answer doesn't match up, then man, go back and look where your mistake is, because it would be like a little minus or a plus or something silly that you're doing to get that mistake. So as I said, that's basically it, I think, for this question, because we got the final answer. You can actually leave your answer as 10 ln of 10 minus 9. That is absolutely fine. As for the marking schedule, I actually want to show you guys the marking schedule because it's a bit strange. So as you guys can see, with the marking schedule, what's happening is that for achieved, there's a 20x minus e to the power of 2x over 2. I guess that if I'm correct, they might have made a mistake that they forgot the 2 there. Correct solution with correct integration gets you an excellence. Correct integration, geez. Oh, maybe, yeah, I'm not sure how you can get an achieved in this with this, because nothing of that is actually there. Because even if you look at the original equation, we got 20 minus 2e 2x, so there's never, we got over 2. Strange one to get an achieved, but because in the next one it says correct integration, so obviously if you do the correct integration, you're going to get a merit, but if you do like a botched job, you get an achieved. Can't tell. Cool. So let's go back to what do we got? What have we got? Yeah. So going back to this, we're going to get excellence for this. Merit, I would say, is getting the right integration, and I guess achieved is somewhere if you end up making a mistake, I think. Cool. So that's question 2 for us. Let's go to the next one. All right, guys, so let's get started with question 3. Question 3a, what you have is this reverse chain rule question. Now, some people would like to expand this. You're more than welcome to do that, but that is going to kill a lot of time. But basically, or you could use substitution as well. That's pretty easy, that one. That could actually work out. But if not, we're just going to do reverse in this. So doing reverse, basically write the function as it is, but we're going to add 1 to the power. So that means it's going to be plus 1. Divide by the new power, which is 3 plus 1. And also divide by the differentiation of whatever's inside the bracket. In this case, it's going to be 2. And so we're going to divide by that as well. So when we do this, we're going to get 24. Don't forget the plus c. 24, 2x minus 1 to the power of 4 divided by 8 simplifies to 3, 2x minus 1 to the power of 4. Gets you an achieved grade, and we move along to the next question. So question B, what we have is solving the differential equation, and given that when x equals to this, y equals this. So basically it's just integrating it and solving it, right? So we're going to put this up here as dy is equal to 4 sec squared 2x dx. And remember that when you have tan, when you differentiate tan, you're going to get sec squared. So that means y is equal to 4 tan squared tan 2x, not squared, because tan differentiates to sec squared. And so when going backwards, it's going to just be tan. And of course, we've got to divide by the differentiation of whatever's inside this bracket, which is going to be 2. And don't forget the plus c. So we've got y is equal to 2 tan 2x plus c. And now we've got to actually finish the equation. So we've got to actually figure out what the c value is. So remember that x is equal to pi over 8. Y is equal to 5. So we've got 5 is equal to 2 tan 2 times pi over 8 plus c. Now tan of pi over 4 is equal to 1. So we're going to get 5 is equal to 2 times 1 plus c. So we can see that c is equal to 3. All right, but we want to actually write the equation. So our equation is going to equal y is equal to 2 tan 2x plus 3. And gets you an achieved for this question here. Now, if you just write down 2 tan 2x, and you get nothing else correct in this question 3, then you can possibly get an N2 for it. All right, but let's hope that we're not going to that desperate situations. Anyway, going to next question, question C. So question C here, what we've got is, what can we do here? So with question C there's a couple of ways of doing this, right? So you can actually do it by substitution, or you could actually use long division. What I mean by long division is I'm looking at this particular thing here, the x over x plus 1. All right, so if I was to use long division, I would do something like this, x plus 1 over x, multiply that by 1, so I'm going to get x plus 1, and what I got is x minus x is 0, 0 minus 1 is negative 1. So what I can say is x over x plus 1 could be written as 1 plus negative 1 over x plus 1. So basically, I could do this with long division, and I can actually replace the x plus 1, x over x plus 1 with 1 plus negative 1 over x plus 1. All right, so that is actually one way of doing this. And the other way of doing this is by substitution. Now, if you're not comfortable with long division, then substitution will actually work really well as well. So with substitution, and again, as I said to you, this question, you can actually do it 2 different ways, long division or substitution. And I've kind of done it already with the long division, because all you have to do, the next step is just put it 4, 1, x plus 1 plus 1 minus 1 over x plus 1 dx. So if you actually do this, just remember that 1 over x plus 1 is ln. When it integrates, it becomes ln of x plus 1, and you're done. Okay, so that's if you're comfortable with long division and you want to do this method. But let's say you want to do substitution. And the reason why I want to choose substitution was because in this particular paper, I haven't actually had the opportunity to show you guys how to do substitution. So that is why I'm doing substitution. So I'm going to put down u is equal to x plus 1. Therefore, u minus 1 is equal to x. So this is what I'm going to do. So I could potentially just do all the substitutions straight away, because you know how at the top here you've got, it's going to choose a different color, you've got 4 and 1. Because you've got 4 and 1, you can actually you need to change the limits for the u1 as well. And the way we're going to do it is by using the u, because if it's 4 plus 1, then this is going to be 5. And then if it's 1 plus 1, then it's going to be 2. So my 2 new limits are going to be 5 and 2. And notice how this part here is, you should use a different color, hang on. Because I said that u is equal to x plus 1, I could replace this x plus 1 with u plus x over x plus 1. X plus 1 is also u. And I've still got dx there. All right, now I haven't actually fully substituted all the x's out, because there's still a x and there's still a dx. So remember that x is equal to u minus 1. So I can actually replace that with, so I've got 5 to u plus u minus 1 over u. And I've still got the dx. So I need to get rid of the dx. And the way I'm going to get rid of the dx is by differentiating u, because u is equal to x plus 1, which means du over dx equals to 1, because when I differentiate it, and then cross multiplying, I'm going to prove that du equals to dx. And because du is equal to dx, I can get rid of the dx in the next line with du. So this is all going to become 5 and 2, u plus u minus 1 over u du. Now just differentiate, integrate it, and you're good to go. So before I start integrating, I want to separate that u. So I've got 5 over 2 u plus u over u minus 1 over u du. And again, keep going. 5 over 2 u plus 1 minus 1 over u du. Now I can finally integrate it. And of course, I'm going to run out of space. So integrating this, u will become u squared over 2. 1 will become u. Minus 1 over u becomes ln of u. And this is all between 5 and 2. So substituting in, I've got 5 squared over 2 plus 5 minus ln of 5 subtracted with 2 squared over 2 plus 2 minus ln of 2. Which means I'm going to get 25 over 2, which is 12.5, plus 5, which is 17.5, minus ln of 5, minus 2 squared over 2 is 4 over 2, plus 2 is 4, minus ln of 2. Expanding it, I'm going to get 17.5 minus ln of 5, minus 4 plus ln of 2. So you could actually put this in the calculator and get the answer. So 13.5 minus ln of 5 plus ln of 2. Let's actually put it in the calculator and see if we're on the right track. So that means I've got to go integral sign of x plus 1 plus x divided by x plus 1. And that is between 1 and 4. So it's giving me 12.58, and then let's check my answer here. So I've got 13.5 minus ln of 5 plus ln of 2. There you go. I'm on the right track. So that is basically what my final answer is, and I'm going to leave it at that. So achieved is for integration, correct integration. So we're looking at somewhere here, or in the original equation when you did using the long division. If you did use the long division, you would have probably got, let's just do that really quickly on the side here. So you got x plus 2 minus 1 over x plus 1 dx, which means you're going to get x squared over 2 plus 2x minus ln of x plus 1, and that's between 4 and 1. So that's what you would have got here for an achieved. And of course, your merit grade is your final answer for this question. Okay, let's go to the next one. Question D here, guys. All it is it's an ugly question. That's all. That's all I'm going to say. It's an ugly question, but doable. All right. As I said to you before, like if you are struggling with integration, it's like learning substitution goes a long way. But in this one, even substitution is going to not help you as much. Well, yeah, nah, it's not going to help you because there's like square root in there as well. But it's almost like treating it as two separate ones and then combining it, then yeah, it'll work. So basically what I'm going to be looking at is I'm going to be looking at this right here. Notice how it's 4x squared, and then in the numerator I've actually got 4x. Now I know that if I differentiate 4x squared, I'm going to get 8x, and that means I'm doing something with ln here. That's what I got to kind of work with. And I'm going to be honest here, as you do more integration questions, you'll start recognizing these patterns. And then once you recognize the patterns, it becomes just a little bit more, yeah, it just becomes a little bit more easier. But the way I kind of work this out is this. I've got integral of 4x over 4x squared minus 3 plus x to the power of half. Basically, y is equal to this, right? So the next part is, because it's 4x squared minus 3, I mean, I can put it as ln. So I'm going to rewrite this as 4x multiplied by ln of 4x squared minus 3. And I've got to divide by, and this is what I end up doing, divide by the differentiation of this, which ends up being 8x. Plus x to the power of a half plus 1 divided by a half plus 1. And of course, it needs the plus c as well. So 4x over 8x is 1 over 2. So it's going to become 1 over 2 ln of 4x squared minus 3 plus x to the power of 3 over 2 over 3 over 2 plus c. So again, correct integration is going to get you an achieved. So getting up to here is going to get you an achieved. Now, it says that y of 1 equals to 2. All right, so basically it says y of 1 equals to 2. That just means that when x equals to 1, y is equal to 2. So we're going to put this in this equation. So we got 2 equals a half ln of 4 times 1 squared minus 3 plus 1 to the power of 3 over 2 divided by 3 over 2 plus c. And we've got to try and figure out what that c is. So we're going to get 2 equals a half ln of 4 minus 3 is just 0 plus 1 over 3 over 2 is 2/3 plus c. So we're going to get 2 equals 2/3 plus c, and we can say that c is equal to 2 minus 2/3, which gives us 4 over 3. So we've got the equation now. Our equation for y is equal to half ln of 4x squared minus 3 plus x to the power of 3 over 2 over 3 over 2 plus 4 over 3. And we've been asked to find what y of 4 is. So basically put 4 back into wherever x is. So we're going to get 4 times 4 squared minus 3 plus 4 to the power of 3 over 2 over 3 over 2 plus 4 over 3. Looking how ugly this thing is, I got to use a calculator. So what do we got? We've got 0.5 ln of 4 times 4 squared minus 3 plus, this is going to be fun, isn't it? We're going to go 4 to the power of 3 over 2, which is 1.5, divided by 1.5 plus 4 over 3. And I got an answer of 8.722. So could we have done this any other way? Ooh, off the top of my head, no. I think it's because I'm tired from doing this paper. Long papers always take a bit of energy. But anyway, guys, 8.722 is the answer we're looking for. That's going to give us a merit. Cool. So let's go to the last question. Lots of reading there to do, so take a moment. All right, guys. So this question here, basically, I've seen it come a couple of years ago, or maybe it was about 3 years ago. It's actually not a complicated excellence question. On first looks, it looks like, what the hell are they doing here? But in reality, it is just a matter of substituting everything in there in a proper way, all right? So let's actually go through this question one thing at a time. Now, the first thing is that we've got this capital H. Capital H is going to be, as you guys can see, I'm just going to take some time to highlight. So the capital H is the tank height itself, which is going to be 1.5. Okay, so I'm going to rewrite this equation right now. So E is equal to 9,800. Capital H, oh, there's a capital H there as well, right here. That's going to equal 1.5. So any other capital H's? I've got another capital H there. So let's put that down there. So that's going to be 1.5 and 1.5 minus something. And I've got 1.5 minus. Okay, now the next thing is the little h. So if we have a look at the, actually not even, let's look at the letter D, right? So the D is the initial depth of the water in the tank. And that's right here, the initial depth, which is 1 meter. So we can actually put the little d, which is highlighted here. That's going to be 1. So far, so good. Next is the little h. The little h is something that we actually don't know what it is, because that's the depth of the water at any instant, and so it's a variable. All right, that means that h is going to constantly change, which means we don't know what that is. So we're just going to leave it as h. Then what we have is this area of h and dh. So dh is fine because we know we're going to integrate it with dh. We got to figure out what that a of h is. And so if we go have a look at a of h is the area of the surface of the water at this instant. So basically, we're actually looking for that surface. So that's like it's a square. I hope you guys can see that. Like that's that this part right here. That's what area of h is. So I need to come up with a formula for that area of h. That's what I need to do, because that's the last bit that's actually missing. If I get that, then the rest of the question is like easy. So think back to what are the things that you could actually use. Can you use trig? Well, we don't really have any angles. So let's actually draw this out. If we were to draw this out as a little cross-sectional area, then what you should see is that this is 0.9 and this is 1.5 so far. Now what we need to know is that we're trying to find what that area is at any given height. Now we don't know what the height is. The height is going to be here. And I'm hoping that by just drawing this out, you guys can actually see that you have to use similar triangles. Because what you should see is that 0.9, which is the length from here to here, it's got to be proportional, like it's got to be some sort of relationship between that and h as well. So what you could do is you can actually write 0.9 over 1.5 is equal to, I'm just going to call this x for now, x over h. So 0.9 over 1.5 is 0.6 equals x over h, and then x is equal to 0.6h. So basically what I've just discovered is that this length of that square, or the side of that square, is actually equal to 0.6h. So if the side of it is 0.6h, then remember that area of the square, so because it is a square pyramid, area of square is going to be base times base. And because the base in this case is 0.6h, we're going to do 0.6h times 0.6h, which gives us 0.36h squared. Now that is the formula for the square pyramid, not square pyramid, the square, the surface area of the water, which happens to be a square. So now that we got that 0.36h squared, we can actually go in and substitute it in. So that means our E formula now is going to look like this. E is equal to 9,800 between 1.5 minus 1 is 0.5, 1.5 minus h, A of h is 0.36h squared dh. So with this in mind, we're going to expand the bracket and we just have to integrate. That's all we have to do. So we're going to get 1.5 times 0.36, 0.54 h squared minus 0.36 h cubed dh. So E is equal to 9,800 and in the bracket 0.54 h cubed over 3 minus 0.36 h to the power of 4 over 4, and that's between 1.5 and 0.5. So putting this in, just substituting all the values in, so we're going to get 9,800 multiplied by 0.54, 1.5 cubed over 3 minus 0.36, 1.5 to the power of 4 over 4. Of course, that has to be subtracted with 0.5 on as well. So 0.54 times 0.5 cubed over 3 minus 0.36 times 0.5 to the power of 4 over 4. Super ugly equation is all I could say. Maybe I should have actually simplified that 3 and 4. Would have made it a bit easier. Yeah, it's all right. So I want to know if this is right or wrong. Right now, here's the thing. Again, I've got the calculator, so I'm just going to quickly just check what my answer is. So go into integral. 0.54 x squared minus 0.36 x to the power of 3, and that's between 0.5 and 1.5, which gives me 0.135. But remember, I got to multiply that by 9,800. So my answer that I'm supposed to get is 1,323. And basically, I got this long-ass equation that I got to put in the calculator to try and see whether it actually works or not. So let's do this. Sorry guys, you might want to skip forward for this one, but that's how it is going to work. So in my bracket, I've got 0.54 multiplied by 1.5 to the power of 3 divided by 3 minus 0.36 times 1.5 to the power of 4 divided by 4. Let me just see if I get that right. It's never a good idea to do this. Just had a deja vu moment. Yeah, I did too. All right, let's actually hit this through. So we've got 0.54 multiplied by 1.5 to the power of 3. That's all divided by 3 minus 0.36 multiplied by 1.5 to the power of 4 divided by 4 minus, make sure you put that bracket around there, buddy, so 0.54 multiplied by 0.5 to the power of 3 divided by 3. That's going to become plus because it's minus and minus, plus 0.36 bracket 0.5 to the power of 4 divided by 4. Ah, where's my mistake at? Right, I don't need that bracket there. Get rid of that. 0.135, and I'm going to multiply it by 9,800. Yay, 1323. So E is equal to 1323. Long and painful. Cool. So let's see, what do we need to do for merit achieved and excellence? Lovely question. No achieved at all. No achieved. Yeah, go straight into merit. So correct integration gets you a merit. I guess the reason why you'd want to give a merit for correct integration, I guess, you know, you could make a mistake and you can still show some sort of errors. Would that count? I'm not sure. Final answer is correct solution. Excellence is correct solution with correct integration. So You got to do both to get that E grade. Otherwise, this question is just a merit or an excellence grade question. So guys, I do apologize, long bit of working for question 3E. But hey, it is what it is. I think that's why they made the integration part of this very, very easy. Like, it's just putting all the pieces together with that formula. That's all it is. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.